So basically there are two sections for 10.3 here. We're looking at what are called double angle formulas, and we're looking at half angle formulas. And we're going to do these for pretty much sine and cosine, although we'll look at how we can get around. We can do tangent as well by simply viewing tangent as sine over cosine. So let's consider double angle formula. What do I mean by that? Well, what's, for example, the sine of 2 theta? And you might want to compare, say, the sine of 2 times 30, sine of 60, with 2 sine of 30, and note that they're not the same. So the sine of 2 times theta does not equal 2 times sine of theta. We'll actually do that out. 2 sine of theta does not equal sine of 2 theta. Except in special cases, for example, if you had 0, 2 times sine of 0 would equal sine of 2 times 0. But in general, for angle measurements other than 0, it doesn't work. So how do we find the sine of 2 theta? How do we find, for example, the cosine of 2 theta? And what would it mean to have a half angle formula? In other words, suppose I wanted to know what's the sine of x over 2, or the cosine of x over 2. So that's our goal for this section. So we do have a formula for the sine of alpha plus beta. And if we consider alpha plus beta, if we look at the sine of 2 theta, let's say, we could simply think about that 2 theta as theta plus theta and simply plug that in for alpha and beta. So if I do that, I get sine of theta, cosine of theta, plus cosine of theta, sine of theta. And if I simplify that, I get 2 sine theta, cosine theta. So that's my formula for the sine of 2 theta. And note there's only one formula for the sine of 2 theta. It's 2 sine theta, cosine theta. So we can do the same thing here if we're trying to find the cosine of 2 theta. Consider 2 theta. We know the formula for the cosine of alpha plus beta. Just consider that 2 theta, split it up into theta plus theta, and then use our cosine of alpha plus beta formula. So that would then be cosine of theta, cosine of theta, minus sine of theta, sine of theta. Simplifying that, I get cosine squared theta minus sine squared theta. That's the cosine of 2 theta. Now, here's the issue. I can replace cosine squared with, from my Pythagorean identity, 1 minus sine squared theta. I could also replace sine squared with my Pythagorean identity with 1 minus cosine squared. When I do that, and you can verify it easily, it's arithmetic, you wind up with 2 additional formulas for the cosine of 2 theta. Now, I think it's a good idea to memorize these and not to derive them each time, not to derive the second 2 from the first one. I think they're at least for the next little bit, they're pretty good to keep in your short-term memory. And they turn out to be 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. So again, we have 3 formulas for the cosine of 2 theta. And what that's going to mean is at times when you're simplifying or proving an identity and you've got a cosine 2 theta in it, you got to say, well, which one of these is going to be the most useful for me to plug in? Well, suppose you're trying to simplify something and it looks like everything's involving cosines. Well, then maybe you want to use the 2 cosine squared minus 1 instead of the other 2 that have some sine squareds involved in them. And you might have to play around. But just know that when you substitute for cosine 2 theta, you got 3 choices. Okay, so lots of writing here. We're going to go through it slowly. We're going to find our half angle formulas by looking at two of our formulas for cosine of 2 theta. 1 minus 2 sine squared and 2 cosine squared minus 1. And both derivations are exactly the same. The key here is to notice that 2 alpha is double alpha. So I need a ratio here of 2 to 1. I can do that by writing this as 1 to 1/2. Note that 2 to 1 equals 1 to 1/2. So I'm going to rewrite this expression as cosine of x equals 1 minus 2 sine squared of x over 2. And the goal is to solve for the sine of x over 2. To do that, I'm going to bring this expression over here, over to the left side. I'm going to move the cosine x to the right side. Then I'm going to divide both sides by 2. And then when I take the square root, I must put in a plus or minus. So the sine of x over 2 is either the plus or minus the square root of 1 minus the cosine x over 2. Again, notice the relationship here. This angle is half of this angle. This is why it's called a half angle formula. And ditto over here. Again, the 2 alpha is twice alpha. Replace that with an x and an x over 2, so I keep my 2 to 1 ratio. And I'm solving for cosine of x over 2. And I can simply do that by moving the 1 over to the other side. So I've got 2 cosine squared of x over 2 equals 1 plus cosine x. Divide both sides by 2. Take the square root, and I get the cosine of x over 2 is plus or minus 1 plus cosine x over 2. Do you want to have these formulas memorized? These two right here. And I'm going to suggest that yes, indeed, you do want to have those memorized. You do need them memorized. What's interesting about these formulas, again, we're going to play with them now. We're going to play with them with identities, with some problem solving, with some finding some exact angle measurements. But they are going to be useful in calculus when you need to integrate at times. You're going to be able to integrate, for example, linear expressions up here, whereas it's more difficult to integrate a squared expression here. So these double angle and half angle formulas are going to become useful. They will come back into play in calculus next year, and we're just going to play around with them right now. So I'll show you an example problem here with the double angle formula first. So here's the question. Suppose you were asked to find, without a calculator, you want to find an exact value for the sine of pi over 12. And I note that the sine of pi over 12, well, pi over 12 is half of pi over 6. So think about your half angle formula. The half angle formula is sine of x over 2 equals the square root of 1 minus the cosine of x all over 2. And look at your ratio here. X over 2 is 1/2 of x. So if I am looking at the sine of pi over 12, if this value here is pi over 12, my value over here is going to be double that, which would be pi over 6. Note, I can find the cosine of pi over 6. So I go ahead and do that. I get the sine of pi over 12 equals the square root of 1 minus the cosine of half, double pi over 12, which is pi over 6, all over 2. And this is all under the square root. And you could say, hey, I found an exact value. I'm all set. There it is. Well, the first thing to consider is we didn't really think about that plus or minus that we just talked about. When you take the square root for these formulas, there was a plus or minus right there. We deal with that by looking at this expression right here. In what quadrant is pi over 12? First quadrant angle. Is the sine of a first quadrant angle going to be positive or negative? Clearly the sine of a first quadrant angle is going to be positive. So I'm going to pick the positive portion of the formula, of your half angle formula. So continuing to simplify here, I've got 1 minus the cosine of pi over 6 over 2 all under the square root. So I'm just going to go ahead and continue to simplify that. That's going to be 1 minus. The cosine of pi over 6 is root 3 over 2. And all of that's over 2. And all of that's under a square root. Hopefully you're remembering, again, from Algebra 2 and pre-cal earlier this year, is that we can eliminate denominators, these complex fractions, these nasty fraction over fraction things, by clearing denominators. And I can do that by multiplying under the square root by 2 over 2. If I do that, note then, 2 over 2 is 1. I haven't changed anything. But then I can rewrite this, carry that 2 through the numerator, and you're going to get a 2 minus root 3. And think about the denominator. This is actually square root of 1 minus root 3 over 2, that quantity times 2, over the square root of 2 times 2. Well, the square root of 2 times 2 is 2. So I'm done. I have found an exact value for the sine of pi over 12. So we said we'd talk about what to do with tangent a little. If we wanted to look at the tangent of, say, 2 theta, we could view that as the tangent of theta plus theta and simply plug that into our tangent of alpha plus beta formula. So that turns out to be then tangent of theta plus tangent of theta over 1 minus tangent of theta, and I simplify that and I get the tangent of 2 theta equals 2 tan theta over 1 minus tan squared theta. Now, just as kind of a nifty little example, and it's nifty just because it allows you to find something 2 ways. Suppose we had the cosine of pi over 4. Now we can find that directly. The cosine of pi over 4 is root 2 over 2. That's one we know from one of our basic fundamental angles. Multiples of pi over 3, pi over 6, pi over 4, or quadrantal angles. Could I view this as a half angle situation? And the answer is, of course I could. Half angle formula. Cosine of pi over 4, well, that's half of pi over 2. So I could look then and say that the cosine of pi over 4, and we want to say, well, where is pi over 4? It's the first quadrant angle, so I'm going to pick the positive square root of 1 plus cosine of, remember this would be double pi over 4, pi over 2, all over 2. And if I simplify that, I get 1 plus, well, the cosine of pi over 2 is 0, all over 2, and that gives me 1 over root 2, which gives me root 2 over 2. So indeed, obviously, it has to be consistent. If we use a half angle formula to get cosine of pi over 4, it has to turn out to be the same, it has to be root 2 over 2. So one final example. I'm supposed to find an exact value of an expression like, say, cosine squared of pi over 8 minus sine squared of pi over 8. And I look at that and say, well, now wait a minute. That looks like a cosine squared theta minus sine squared theta, and I know that that's the cosine of 2 theta. Great. So again, notice my ratio here. Theta to 2 theta is 1 to 2. So this has got to be half of, this is going to equal the cosine of 2 times pi over 8. So then I've got cosine squared of pi over 8 minus sine squared of pi over 8 equals the cosine of 2 times pi over 8. Well, 2 times pi over 8 is pi over 4, so I'm actually looking at cosine of pi over 4. And I know cosine of pi over 4 is root 2 over 2. So, indeed, cosine squared of pi over 8 minus sine squared of pi over 8 is root 2 over 2. Okay, so for number 50 here, I'm going to give you a couple hints. Note that we don't have any formulas for the cosine of 3x. So what we can do is break that up into cosine of 2x plus x, and then use your cosine of alpha plus beta formula. Note when I do that, when I expand this, I'm going to get a cosine 2x, I'm going to get a sine 2x. The sine 2x there's going to be only one formula for, 2 sine x cosine x. But the cosine 2x, when I expand this here, I've got 3 choices. I've got 2 cosine squared x minus 1, I've got 1 minus 2 sine squared x, or I've got cosine squared x minus sine squared x. Look at where you're trying to go. You're trying to get everything in terms of cosines. So when you pick that formula for the cosine of 2x, you might want to consider using the 2 cosine squared x minus 1 instead of mixing and bringing in a sine squared, a 2 sine squared, or a 1 sine squared into your expression. And you might have to play around. You know you're going to have to expand this. You're going to get a big mess. You're going to have to simplify, but you know where you're supposed to end up.